Welcome to MacroCode, and today we are going to learn something very interesting. So if you are new to this channel, consider subscribing and watching our previous videos. So today we are going to learn about Docker, do an introduction about Docker. So Docker is one of the most popular containers-based platforms, attracting the attention of many development teams. So more and more companies are switching to use Docker due to its reliability, performance, and functionality. So it is actually important for us today to understand why Docker is being used mostly. So on our today's video, we are going to learn what is Docker, be able to understand what are containers, and the next thing that we'll be able to see is what is a Docker used for. So why do we use Docker, and what Docker and how Docker help us in our development our works. So the next thing is we'll be able to see the Docker core components, some of the Docker core components, and be able to have a very high level of it in our next series. So for today, we are going to highlight and understand what are the Docker core components. Then we'll be able to see what are the importance and what are the advantages of Docker. Then we'll be finalizing with the disadvantages. So Docker disadvantages and how does it impact our day-to-day activities when dealing with software development. So what is Docker? Some of you may be wondering and asking, what is Docker? So Docker is an open source containerization platform used for developing, deploying, managing applications in lightweight virtualized environments called containers. So it is mainly used as software development platform for developing distributed applications that work efficiently in different environments. So by making the software system agnostic, developers doesn't have to worry about compatibility issues when using a Docker. So packaging apps into isolated environments called containers, and it's also make it easier to develop, deploy, maintain, and use applications. So Docker, since Docker utilizes virtualizations to create containers for storing apps, the concept may seem similar to virtual machines. So we'll be able to see what are the difference between Docker and actually virtual machines. So although both represent isolated virtual environments used for software development, there are important differences between containers and the virtual machines. So don't confuse containers and the virtual machines. So we'll be able to understand the difference between containers and virtual machines in our next video. So the most crucial distinction is that Docker containers are lighter, faster, and more resource efficient than virtual machines. So for today's video, we are not going to deal with virtual machines, but we'll be able to see what are containers. So what is a container? So when you talk about a container, what is it? So Docker containers are lightweight virtualized runtime environments for running applications. So each container represents a package of software that contains the code, system tools, runtime libraries, dependencies, and configuration files required for running a specific application. So containers, they are actually independent and isolated from the host and other instances running on that host. So containers are based on Docker images. So we'll be able to see what are actually Docker images. So containers are actually based on Docker images, and you build a container by running an image on the Docker engine. So as these are the most common Docker terms, we'll be able to use to actually see what is the difference between the Docker image and the Docker containers. So the same hardware that can host multiple containers is actually, so we can have the same hardware that can host multiple containers, unlike the virtual machines. So containers are virtualized at the application level. So therefore they share the OS kernel with the host and virtualize an operating system on the top of it. So this means that you can So these are the Docker containers. So you can see we have the Docker containers and we have the virtual machines. So I've tried to put in a very simple distinction, but we'll be able to dive in on our next video about the Docker containers and the virtual machines. So you can see they share, so you can see the infrastructure at the bottom of it. Then we have the host OS at the top of it. Then the difference now comes in for the Docker containers and the virtual machines is the Docker engine, but the other one for the VM we use hypervisor. So the hypervisor hosts the guest OS, but for the Docker engine hosts the different applications. So on top of each application, we have the containers. And for the guest OS, we have the OS, then application, then we have the virtual machines. So that is the difference. So today, we are not going to dive deep into the differences, but we look that in our next series. So one thing to note is that containers do not have a direct communication with the host. However, you can grant the instance root capabilities by running a container in privilege mode. So to maximize container performance, you usually make use to implement Docker container-based practices, and we'll be able to see these in our next series. So for today, let's see what is Docker used for. Some of you may be wondering, why do we need Docker? And how does it help us? So we need Docker because one, it is used for running multiple workloads on fewer resources. Docker will help you if you have fewer resources. And that is why we need Docker. The next thing, the next advantage of it is, why do we need Docker? It helps us in isolating and segregating applications. Then the next thing on how we use Docker, Docker is used for standardizing environments to ensure consistency across development and release cycles. So you can imagine developing applications with different environments. It can work on one environment, then it cannot work on a different environment. But with the use of Docker, it helps you to standardize environments to ensure consistency across development and releases cycle. So Docker is used also for streamlining the development lifecycle and supporting the CI/CD workflows. So we'll be able to see the CI/CD workflows in our next series. So keep in touch, subscribe so that you get a notification for our next post. So Docker is also used for developing highly portable workloads that can run on multi-cloud platforms. So that is the importance of why we use Docker. Also, Docker is used as a cost-effective alternative to virtual machines. So Docker is actually used as a cost-effective alternative to virtual machines. It is also used as a version control system for an application. So to give you a brief history of Docker. So Docker was introduced as an open source project in March 2013 at PyCon. So before focusing on containers, the project started as a platform as a service solution called .cloud. So in 2008. So however, many developers showed great interest specifically for the underlying technology of .cloud, that is the software containers. So since then, Docker has been drawing attention of many technology providers and high-profile companies. So we'll be able to see those comparison of even Docker and Podman. So the next thing that we need to see is the Docker core components. So what are the Docker core components? So the Docker tool consists of multiple components, each playing an important role in the platform. So one of the component is the Docker engine. So the Docker engine is installed on the host machine and represent the core of the Docker system. So it is a lightweight runtime system and underlying client server technology that creates and manages containers. So Docker engines consists of actually three components. We have the server, which is actually the Docker daemon, which is responsible for creating and managing containers. Then we have the REST API, which establishes the communication between programs and Docker and instruct Docker card what to do. So we also have the command line interface, CLI, which is used for running Docker commands. So that is the core components of Docker engine. So the next component of Docker is the Docker images. So what is a Docker image? So Docker images are templates used for building containers. So these are the templates used for building containers. So like snapshots for virtual machines, Docker images are immutable, read-only files that consist of the source code, libraries, dependencies, tools, and any other files necessary for running an application. So each image is created from a Docker file, so which contains specific instructions for building a particular Docker images. So once you master creating Docker images from the Docker file, you can build images and custom containers simple and faster. So apart from the speeding up Docker builds, images are also used for creating reusable and essential decreasing disk use. So this is an example of a Docker component. So we have the Docker images and we have the Docker engines. So our next Docker component is the Docker file. So a Docker file is a script. So when you talk of a Dockerfile, it's actually a script that consists of a set of instructions on how to build a Docker image. So these instructions include specifying the operating system, languages, and Docker environment variables, file locations, network ports, and other components needed to run the images. So all the commands in the file are grouped and executed automatically. So an image has multiple layers. Once you run a Docker image to create a container, a new read-write layer is added. So this is sometimes referred to as the container layer. So the additional layer allows you to make changes to the base image, which you can commit to create a new Docker image for future use. So Dockerfile is actually like a script. So you can assume it like a script which consists of a set of instructions on how to build a Docker image. So this is the third Docker core components. We have seen of the Docker engine, the Docker image, and we have seen the Docker file. So the next thing is the Docker hub. So you can look for the Docker volumes. So what is the Docker volumes? So Docker volumes, instead of adding a new layer to an image, instead of adding a new layer to an image, a better solution is to preserve data produced by a running container, and that is using Docker volumes. So these help us to allow users to save data, share it between containers, and mount it to new ones. So Docker volumes are independent of the container lifecycle as they get stored on the host. So there are different ways to create and mount a Docker volume while launching a container. So we'll be able to see that in our next video. So you can see from our screen there, we have the directory in host machine and the Docker containers inside the host machine. We have the container 1, container 2, and the container 3. So our next component is the Docker compose. So when running and managing multiple containers simultaneously, Docker compose is useful tool to design to simplify the process. So it strings multiple containers needed to work together and control them through a single coordinated command. So Docker Compose is used actually to launch, execute, communicate, and close containers with a command. So this is done using a YAML file, which configures the application as services. So that is the Docker Compose. So this is actually used when running and managing multiple containers simultaneously. The Docker Compose is a useful tool designed to simplify the process. So our next core component is the Docker Desktop. So Docker Desktop formerly was called Docker for Windows or Docker for Mac. So it is actually an application that allows you to start creating and running containers on Windows and Mac with minutes. It is a simple way of installing and setting up the entire Docker development environment. It includes the Docker engine, the Docker Compose, the Docker CLI client, the Docker Content Trust, Kubernetes, and the credential helper. So this tool is used for building and sharing containerized applications and microservices in multiple languages and frameworks on any cloud platform. So those are the Docker main components. So some of you may be wondering, what are the advantages of now using Docker? So one of the advantages is the consistency that Docker gives us. So Docker ensures reliability, that your app runs the same across multiple environments. So developers working on different machines and operating systems can work together on the same application without environmental issues. So that is one of the best advantages of Docker. The next thing is automation. So the platform allows you to automate tedious, repetitive tasks and schedule jobs without manual intervention. So our next advantage is the faster deployments. So since containers virtualize the OS, there is no boot time when starting up container instances. Therefore, you can do deployments in a matter of seconds. Additionally, you can share existing containers to create new applications. So further advantage of using Docker is it supports CI/CD. So Docker works well with CI/CD practices as it speeds up deployments, simplifies updates, and allow teammates to work efficiently together. So the fifth advantage of using Docker is it allows rollbacks and image version control. So a container is based on a Docker image, which can have multiple layers, each representing changes and updates on the base. Not only does this feature speed up the build process, but it also provides version control over the container. So this allows developers to roll back to a previous version if the need arises. So the sixth advantage of Docker is resources and cost efficiency. So as containers do not include guest operating systems as virtual machines, they are much lighter and smaller than virtual machines. So they take up less memory and reuse components and thanks to data volumes and images. So also, containers don't require large physical servers. They can run entirely on the cloud. So apart from the disadvantages of Docker, so what are the hiccups and the disadvantages of using Docker? So one of the disadvantages of Docker is it doesn't have graphical interface. So Docker is not the best choice if you want to run apps that require a graphical interface. So it is mainly for hosting applications that run on the command line. So another disadvantage of Docker is the security issues. So although Docker provides security by isolating containers from the host and each other, there are certain Docker-specific security risks. So many potential security issues may arise while working with the containers. So you make sure you adopt the best Docker security practices that helps you prevent attacks and privileges breaches. So then the third disadvantage of Docker is learning curve. So even developers experience with VM infrastructure need some time to get used to Docker concepts and how they work with it. So if switching to Docker, make sure to take into account the necessary learning curve. So that is more about Docker. So for today's video, we have been able to learn and understand what is a Docker. We have been able to learn what are containers. We have been able to see why we use a Docker for a brief history of Docker. Then we have been able to see the Docker components, which are the Docker engine, the Docker images, the Dockerfile, the Docker hub. So I think we never mentioned about the Docker hub, but for the Docker hub is the largest cloud-based repository of container images provided by Docker. It supplies over 100,000 images available for use by open source projects, software vendors, and the Docker community. So the platform actually allows you to ship your applications anywhere quickly, collaborate with the teammates, and automate builds for faster integration to a development pipeline. So like GitHub, Developers push and pull container images from the Docker Hub and decide whether to keep them public or private. So Docker Hub is one of the Docker components, very crucial one. Then we have the Docker volumes, the Docker Compose, the Docker desktop, and we have been able to see the advantages and disadvantages of Docker, which is we have the consistency, automation for fast deployments, support for CI/CD, rollback and image version control, resource and cost efficiency. On the disadvantages, we have been able to see that Docker doesn't have a graphical interface, which is difficult for those who are not familiar with command line interface. Then security issues and the learning curve for the developers. So that is an introduction about Docker. So for our next video, we'll be able to see how you install Docker and how you navigate around. So for today's video, we want to thank you for supporting us, and remember to subscribe so that you be part of the team. See you in our next video.